Okay, glad to note our last presentation. Fortunately, it's a little long. What we're going to do now is just sort of recap what we've done so far. So first thing we did again, Sarah this morning, first of all looked at some of the challenges to what we do in fingerprints. Okay, we looked at some basic probability concepts, and I gave an overview of those. And we had a look, and you've had a little play with some first generation probability software. So that's basically what we've done today. Okay. So in this session, what we're going to do is take those ideas and the experience that you had, limited though it is, and just based on a few hours, and we're going to see if we can show how this software may, and I emphasize the may, be beneficial if we integrate it into what we do now. So we're not talking about replacing what we do. We're talking about, could we use this software or a version of this software, somebody else's version of this software? Could we use it in what we're actually doing now? And if we did use it, what's the benefit of using it? And I just sort of stress here that we're not trying to sell this to you. And I'm not trying to sell you a particular software package. I'm not really even trying to sell you a concept. What I want you to do is walk out of the room tomorrow with the basic ideas of what it does, so you can go away and think about it. And then as this discussion develops in the fingerprint community, you're well prepared to go, well, yeah, I've seen that, and actually I think it's a good idea and we could use it there. Or alternatively, I've seen Paul and Sarah's presentation, and frankly, I don't think it has any place in fingerprints at all. And then what I'm going to do is take it a little bit further forward and say, well, if we can, is there anything else we can do with probability? Are there other things that we can do with probability concepts which could actually extend what we do in fingerprints, allow us to do new things? So first of all, I'm going to summarize for you using some graphs what you've seen in the demonstration we did of the software. Now, as a little note at the bottom there, I'm going to present you with some charts, okay, that you can look at. Now, these charts are based on data in the research project, but it's very important you don't use these at a later point in your career. You will actually get a booklet which have these charts in as well. But don't be tempted to say, oh, a likelihood ratio of such and such relates to this number of minutiae in a configuration, because the numbers here are not necessarily going to be accurate enough. Well, they certainly won't be accurate. So we're using this very much as a demonstration. And you're going to recall we had this verbal scale, which we haven't really talked about a lot since then. And we're going to use that in part of this summary of the software and see how that verbal scale might fit in. Again, remember, I'm not saying we're necessarily going to use a verbal scale. It was just another way of looking at those likelihood ratios. So this is going to be my graph. Got two axes. Strangely enough, most graphs have two axes. So along the x-axis, that's the one along the bottom, you've got the number of corresponding minutiae between 3 and 12. Okay, it's not going above 12. Software doesn't work above 12. We've already said above 12, you don't really need probability. And along the y-axis there, we've got likelihood ratios ranging from 10 to the 0 up to 10 to the 12. Now, on that first exercise, that first practical you did this morning, you looked at two prints and you had 12 minutiae and you calculated the likelihood ratio, and they all came out about 10 to the 8. Okay, so, and that was what I would have expected for the software to do. Now, if we map on that line of what the differentiation between extremely strong and strong, this idea of 10 to the power 6 as a likelihood ratio, which it can be used as a borderline between, okay, very strong evidence and so diminishingly small, I can remove it. You can see that 10 to 8 fits nice smack in above that line. So it's in that area where I can say, look, the likelihood of another person, random person, having this configuration of minutiae is so diminishingly small, I can dismiss it, just on the basis of what I've done. Now, what we find if we do this time and time again, using 12 minutiae configurations over a range of different latents and different prints, what we find is we do get a range in likelihood ratios. And remember, again, in one of the practicals, that's what you expected to see. You didn't value each particular number of a configuration as being exactly the same. And here with 12, we see that happening. And this is just an indication of the sort of range we get. And you see it's quite an extensive range. And these bars are grayed out towards the top and the bottom, indicating that I don't know, there isn't a 12 minutiae configuration out there with a really, really low likelihood ratio. It's possible. It's highly improbable. It's so unlikely I can dismiss it. But being a scientist, I can't just dismiss the possibility forever. So I'm just going to allow that to sit there and say. But everything we've ever tested with 12 minutiae configurations has fit nicely and snugly within that box. And the main area of that box, as you see, is around here, and it's fitting well in that extremely strong. So 12 minutiae seems to be a very safe place to be. Okay. And that's what we say. And as I mentioned this before in one of the practical sessions, FSS research indicates configurations of more than 12 minutiae, the likelihood ratio is very high. So we're never going to use probability software. We don't see any need for probability software for configurations which have more than 12 minutiae. Okay. But FSS research has shown that there is a specific configuration of minutiae that can vary. The likelihood ratio for a specific number of configuration can vary. So although it's always very high above 12, there is some variation above 12. Okay. So what I've done now is I'm going to map on those other categories of evidence. And you notice they're not equally spaced. There is a reason for that, which I'm not going to go into, but that's the way it's been constructed. Okay, so you notice that strong and limited are actually slightly larger. But we don't need to worry about that. For the purposes of this presentation and what we're doing, all we need to do is look at these as just some sort of verbal indication of what the numbers mean. So if I'm going to take a latent print or some latent prints and run different numbers of minutiae, I find that the likelihood ratio reduces for different configurations of the minutiae. Again, that's what we all agreed we'd expect to see. The confidence of their definitely coming from that particular individual will drop with the number of minutiae that you're using. It's intuitively obvious that that would happen, and it appears to be backed up by the research. Okay. What you will notice, though, is that it's not linear. Down here between 5 and 6, actually with this particular case, it didn't drop. The configuration of 5 minutiae and the configuration of 6 minutiae had exactly the same likelihood ratio. So it's not a simple numbers game here. There is something about the specificity of configuration, not just about the number in the configuration. Again, what we find for each case is that with a certain number of minutiae in that configuration, you get variation. It's not one likelihood ratio for one particular number. Okay? And here you can see the variation. And you can see that it's dropping down. So as we reduce the number of minutiae in our configuration 12 to 8, what we find is the likelihood ratio reduces, but the majority of cases remain in that extremely strong area. So some latents in that range may have less evidential weight than is expected. So if you remember, we'll come back to that graph later, but if you look at that graph, some of them actually drop a bit lower than we would expect it. When you use the software model, and again after tomorrow when you're using the software model, you'll start to develop this feeling of, well, that doesn't look quite right. And we saw a little bit of that in the practical. So does that suggest that we're getting stuff wrong? If some of those likelihood ratios are less than we're expecting from our experience, does that mean we're actually getting wrong answers? Well, no. Simple reason is we're only measuring the minutiae here. And as we've said consistently through this, we're only measuring a little bit of what you do as an examiner. You definitely use other features. So if we just measure the minutiae, yeah, you might overstate the evidence on that, but it's partly part of the examination. So it's possible that some evidence has been overstated. I will use the phrase egging the pudding, which doesn't mean a lot, I believe, in this side of the pond, but pushing the envelope. If you were reliant on a particular configuration of minutiae as the main reason why you're making that match, it's below 12, you might just be pushing it a little bit more than the evidence suggests. It's not saying you got the wrong person. You can have well the right person. But the observations are not necessarily providing the statistical support that you need to make that decision. Okay? That's the only possibility there. The software will not tell you you're wrong. Now, if we go below 8 and into the 7s and down to 3s, again, exactly the same thing. Yes, it's consistently reducing likelihood ratio. That's what we'd expect to see. And we've still got that variation between different configurations, the same number of minutiae. That's consistent. And if you think about it, that sort of makes sense because we have a pattern of different features that are made up. We know that it's a randomly developed pattern, and that sort of makes sense that you're going to get one pattern which is more unusual than another. And in fact, we do that. In fact, you can go on the internet, you can see examples of this. Those little Mexican smiley faces. Everyone seen that website? You know, a website with all the cores with little smiley faces out and all the rest of it. Well, we don't see lots of those, do we? So there's something about configurations of minutiae. So as the number of minutiae in the configuration drops below 8, we find the evidence gets progressively less strong. That's exactly what we'd expect to see. But what we did see there, a meaningful likelihood ratio, can be generated with correspondences as few as 3. Okay, it was an incredibly low likelihood ratio in the practicals you did. It was like between 2 and 5. But remember, to actually assess and evaluate that as a weight of evidence, we need the context in which it's being used, something that we'll come back and discuss a lot more when we look at latents. So with these low minutiae latents, it's possible that the evidence has been overstated. So we're in that 3 to 8 zone. It's very possible we've overstated the evidence if we relied purely on the minutiae. So again, we're not saying that everyone's made big errors down there. I have no evidence to suggest that fingerprint examiners have made loads of errors. I don't believe we made them. I think we said right at the start, 99.9% of the time, we expect that we're correct. But if we were relying just on the minutiae, then we might again have overstated that evidence. Okay. So the range of likelihood ratio generated also overlaps. Remember we saw in that initial graph, we had 2 for 4 and 5, and they came out with the same likelihood ratio. And those graphs overlap. So the other thing that we see is the likelihood ratios for different numbers of minutiae in a configuration can be the same. And it's possible that a likelihood ratio for 3 minutiae can have the same weight of evidence as one for 4 or 5 minutiae. They exist. I actually don't have any great examples of them, but they do exist. So again, it's not a numbers game. It's not as simple as the more number of minutiae I get, the stronger the evidence. As a general rule, that works. But as an absolute rule, no. It's possible that you can have fewer minutiae and still have stronger evidence. Because, as we pointed out and we discussed earlier, what we're measuring is how specific that configuration is. It's about, if you like, that pattern. That's what we're measuring, not just the number of minutiae. So, okay, that's fine. Thank you very much, Paul. It's all very interesting. Well, what use is this to me? Well, let's see what we can do in our current. We talked about this before, and I mentioned this at the start. This type of research, and there hopefully will be lots of type of research using different models, is helping to validate the use of minutiae to attribute latent source. So one of those key challenges about fingerprint examiners cannot do what they're doing because there's no science. It's junk science. It's not a science at all. It's just an art. It's just a technician thing. You know, that's what we're the challenges we've got consistently over the years. And now we have something to rebut that. Peer-reviewed, properly supported research that says, no, it works. There is justification in what fingerprint examiners are doing. There is validity in latent print examination. Okay. So we're starting to address that issue of the scientific validity. If you go back to the criteria that Sarah introduced, that's what we're starting to address. But we're only beginning to address it. And that's recognizing the fact that, you know, there isn't going to be this day when somebody comes up with research and it says, right, that's it, done it, yeah, we're all sorted. That's all we ever need to know. That's not science. That's not the world. That's not reality. This will always modify and change. So we'll never actually get to a point where we can say we've done it. We'll get to a point where we're confident and then we'll think of something else. So does any of that prevent individualization? Let's go back to that point again. Well, you're going to remember that I introduced this fact that you can't have scientific or mathematical grounds. There's no scientific or mathematical grounds for an individualization. It's not going to happen. It never will happen. It just is not acceptable within those disciplines. But, let's come into but. What this software is doing, and the software that's available at the moment, is just evaluating minutiae configurations. You remember that same thing, this is just part of the examination. We're not evaluating the other features. So we're ignoring the pores and the edges and the scars and the creases and the warts, anything else, ridge flow, are ignored by this software. So this is not providing a complete picture. So we can make some arguments around this. And as I've already stated, I think individualization is a key aspect of what we do. And I don't think it's something we need to throw away lightly. So above 12 minutiae, well, we've said this several times before, those likelihood ratios, we can demonstrate they're so high that, actually the minutiae is enough. We don't need to really worry about anything else. Diminishingly small, can dismiss it. As an opinion, I can individualize. No problem at all. Okay. Of course, if I add other things, so if I had 13 minutiae in my configuration and I had a nice crease going through it, or maybe a nice scar going through it, that's only going to add to the likelihood ratio because that has some value. So if you like, we're going to modify that likelihood ratio and take a scar, for example. Scars are going to be very strong evidence because the likelihood of a scar in a particular place, etc., is going to be fairly specific. Okay, so that likelihood ratio is likely to go upwards. So if I have done anything else in addition to my 13 minutiae, that likelihood ratio is probably only going to increase. It's not going to decrease, which means it's even stronger, more diminishingly small than I can dismiss it. Okay, below 12 minutiae, well, the likelihood ratio on the minutiae may not be as high. So we might not be in that diminishingly small up into that really strong evidence. But again, we can evaluate the other correspondences, and the same principle follows. Okay. The other correspondences will add additional evidential weight to our baseline likelihood ratio. So if you take an example of 12 minutiae configuration, whatever the likelihood ratio is, I've got my creases, my scars, etc., I can add to that. I can modify that likelihood ratio. And more often than not, if I've got the right features, so if I can add sufficient evidential weight to push that likelihood ratio up into my extremely strong. Okay. So if you drop below 2, and when you go below 12, basically what this is indicating is if you want to individualize, you need some more emphasis on things other than the minutiae. And again, another question. When you go below 12 and you're looking at those poorer quality latent prints, are you focusing solely on the minutiae, or do you start looking at other things? Any takers? Do you look at other things, or do you just really just concentrate? Yeah. Do you put more emphasis on the other aspects or the other features within a latent print other than the minutiae below 12 than you would perhaps above 12? Yeah. So once again, the software is sort of backing up what you were doing was right. Yeah, I mean, we got there in an intuitive, empirical way, and this has done it in a little bit more of a statistical, mathematical way, but it's coming out with something that pretty much matches what you do. So it's indicating that the software model is close to reality. Remember, a model is a constructed reality. It's never going to be exactly right. Okay. So the thing about individualization is that this software and software of this type is only going to support the idea of individualization as an opinion. Actually, the continued acceptance of individualization is not something that latent print examiners are necessarily going to be the one to call the shots on, because we're part of a bigger criminal justice system. Okay? We have a big voice in this. We're the ones who are the experts at the end of the day, and we're the ones who should be telling people in language they understand, language that is logical, that this is perfectly good science and perfectly valid. But all stakeholders in that criminal justice system will need to agree. And so it may be the future And I don't think it is personally, but it may be the future, that all of a sudden the courts say we don't accept individualization, we don't want you to do that, we want you just to come out with some qualified method of reporting. I don't think that's actually where we want to go. I don't think that's good for public safety and what we do as a main job. But it's not necessarily, certainly isn't in my remit, and it's not certainly for people in this room to do other than influence and argue why actually we can support what we're doing and we can support that opinion of individualization. Okay. Software tools obviously provide an individualization to move away from the individualizing duality. And this is what you hear a lot about probably. It means we're always going to do possible maybes. We've all heard that phrase. You know, it's all going to be shades of grey. All of the positivity around fingerprints is going to be thrown away. And we're just going to, yeah, they allow you to have these qualified reporting. That's what the probability software allow you to do. And use a probabilistic reporting scale. But none of that says you cannot individualize. Okay, they're not mutually exclusive, if you want to put it that way. Okay. The idea of reporting probabilistically, we'll come back to in a little way. Get this to work. Okay, so we can perhaps identify some benefits of integrating into the current process. So this is just with this first generation software. We know, and what it looks is that the software can be assistance in comparing latent prints with low numbers of minutiae. That seems to be where it's going to be really helpful. Above 12, we don't use it. Between 12 and 3, it seems to have, and we actually think that's probably a good place because we're already saying we need a little bit more support down there. Those lower quality latent prints take a little bit more work, so have an extra piece of information that we can rely on. That's going to be the thing. So that's probably where we're going to have an impact. Okay. It indicates the emphasis needs to be placed on other features other than minutiae. That's what those low likelihood ratios are doing. Well, that's going to point us in two directions. One, it's going to reinforce what we do in terms of looking at other features, this holistic approach. So if you like, it's pulling us away from the numerical approach and saying, yeah, a holistic approach is the way to go. And secondly, it's probably helping future researchers point in the direction of what we need to know more about. And the obvious one is there is pores. Okay, we want to use pores, we need to know how reproducible they are, consistently reproducible. Try and find a lot of research that shows that pores are consistently reproducible. It's not a great deal out there to do that. So this will also help direct future research effort. And you saw a couple, and you'll see more tomorrow, this idea of red flag, this idea that it isn't necessarily going to, it's not supporting you in a sense, but it's going to say, hey, something's not right about this. This likelihood ratio actually looks lower than I would have expected. So why is that? What can I see what it is? And again, hopefully in some of the latents that you deal with in the exercise, you'll see some of this coming out. So it's not necessarily, it's not saying you got it wrong, it's just saying, hey, you might want to look at this a bit more, because this likelihood ratio in this particular case looks a little bit off. In the practicals we saw, some of that could be just the plotting of the minutiae. And that was as simple as that. But it could be just actually something to do with the latent print itself. But one of the things we lack, we've got ACE-V, and there's no reason why we should throw ACE-V away. In fact, we shouldn't throw ACE-V away. ACE-V is a very, very good way of explaining our process. It doesn't need to be thrown away, it needs to be added to. Okay. So we can look at ACE-V and say, well, one of the things we don't really have is an effective and practical method of combining different observations at the evaluation. Okay. So is it possible to do that? So what do I mean by that? Well, if I've got a scar and I've got a crease, I've got some pores, and I've got a configuration of minutiae, and I can run a likelihood ratio, I've got these different bits of information, these distant observations. How do I combine those together? So what would actually be good for ACE-V to develop is this idea of an evaluative framework. This idea of actually having a more, if you like, regimented but more documented way in which we all consistently combine those together. At this present moment in time, that's actually quite difficult to do because there's some bits of information missing. So this, again, is not one of those things you're going to see tomorrow. And I'm not going to go into this in a great depth. This is actually called a Bayes network. And this is just like a schematic just to show you what it looks like. I'm not sure if it helps or not. But ultimately, what it's trying to indicate is that if you have, I mean, here we've put in the likelihood ratios that we're generating and put it in a red box. This is our prosecution and defense hypothesis. If you remember, if you went back to this idea of this Bayesian approach of having competing propositions, and what we can do is feed in the different types of observation we're making. So we got about edges and pores and ridge flows, whatever you want to fit into those, and you're working out the likelihood of seeing them if it truly does come from the individual, and a likelihood of seeing them if it came from another random individual, and combining those together. So what we can do is collect that information through a structured framework. Okay. Now that's a very high view of what it could look like, and like I say, it would take a lot to develop. But if you put that into ACE-V, then you start adding probability models in. I hope you can see that when you start talking about the criteria, you're starting to build in consistency because we're all using the same framework. So transparency is coming because we say, well, this is how we do it. We do it like this and like this. And like. We're just adding a little bit more what we do. Fundamentally, you're doing this anyway. You're just not necessarily articulating. It's the same argument as I made with the probabilistic thing. We're all working probabilistically now using this idea of subjective probability. It's just we don't necessarily articulate it even to ourselves in that particular way. So developing that framework is going to help us combine the different observations. Okay, we're still going to use subjective probabilities until such time as we can develop models that maybe take over from that. Okay. So if we took a framework like that and we actually plugged that into ACE-V, or specifically into the E, what do we achieve? Well, as I just said, and I've come up with this sort of phrase, we end up with an examination which is grounded on case-specific data from a validated model. So we're using a likelihood ratio or whatever our models are as our baseline, with a decision process undertaken using a structured method. So we end up with something that sounds and is explainable and very precise. So that E in the ACE-V that we struggle a bit at the moment, if we're really testing, well, how exactly did you decide that they came from the same individual? We can now say, well, I took this observation, and from this I could do this, and this is the framework that I used to make that decision in, and that's consistent. And we would start to breed that sort of consistency of decision making. Okay. So again, only starts, but it only starts. This is only a start of this process. And again, we're right at the beginning of any ideas around probability, and the simplest idea is this idea of a model. So we're not going to launch into start using Bayesian networks tomorrow. It's going to take a while to get used to this and get used to the way of thinking and develop the right framework. So what about probability in court? Okay. Well, we provide the court with details of our framework. If we're using a framework, we will present the likelihood ratio that's been generated during our examination and other observations. So pretty much, we're just going to tell the court what we did. Okay. And that's what the main sort of points and take-home points of this. This is not beyond the reach of any latent print examiner to do. You do not need a degree in statistics to do this. What you need is suitable training. And I think I've come along before. I'll go ahead of myself here. Okay. But obviously there's going to be some challenges to the software. We've talked about that. People are going to challenge the size of the database, the relevancy of the database. Okay. And we can speculate what those challenges are going to be, as I just did. So when fingerprint evidence is fundamental to the case, okay, or when the likelihood ratio forms a substantial part of the evaluation. Two scenarios here. If we have fingerprints which are fundamental, so remember we went back and talked about a case where it's totally reliant on fingerprints, and it's totally reliant on a fingerprint where most of what you've used in your evaluation is minutiae, and it's a low number of minutiae, and you've relied on your statistical model to help support that, then where am I as a defense expert, where am I going to advise the defense to attack? I'm going to attack that model big time. Because if I knock that model out and show that model to be ineffective, I knock all of your evidence down like a pack of cards. Yep, that's potentially going to happen. But much more likely with these first generation models, if we decide they're valuable to use, is they're going to be used as part of the examination. Might be a substantial part of the examination, but they're not going to be the totality of the examination. So yes, you're still going to get attacked on it, but it's possible that the defense won't choose to attack the model. Because even if they get rid of the model, there's still everything else that you've got. So what sort of challenges? Okay, the underlying mathematics are going to be challenged. How exactly were those likelihoods ratios calculated? Size and constitution of the database. Okay, that's where the sort of main attacks are going to come. There are also other attacks. If you're using a software model, they're going to do things like, well, if you push that particular key A, how do you know that what you think is going to happen happens? Does that make sense? You can just challenge the basic mechanics of how the computer works and just say, well, you don't know, do you, Mr. Chamberlain, that when you push A, that happens? How can you be assured? So there's a lot around this rather than just underlying theory. But that all comes into this validation, as I mentioned before, substantive validation documentation. But what I know as a latent print examiner, and as I said, my interest in this is how is this going to help me be better at my job? How is this going to help me give better evidence, give more balanced evidence? Ultimately, how is this going to help me produce more evidence to get rid of more bad guys? The researchers and developers are the ones who are going to be tasked with backing up the mathematics. They're the ones that are going to have to deal with validation. It's not going to be me. And again, I've used this before, I think, maybe outside of class. If you think about APHIS technology, can any of us in this room explain exactly how an APHIS system works? No. Do we care? No. What we care about is it gives us what we expect. It finds the right person in the database. And, okay, not a great analogy, because you probably don't have to explain APHIS in court very often. But ultimately, this is the same. What we need is confidence in the output and how we use it. If somebody wants to challenge how that got to that confidence level, then let's give that to the experts and the people who know about that. They can explain it. So as latent print examiners, we need to know a little bit of where it comes from. We can't just say, oh, I have no idea. I just push that button and it just comes out of nowhere. We're going to know a little bit, but it may not be a huge amount more than you've seen just today. It will be more, but it won't necessarily be a huge amount more. So you'll be able to answer some of them. When it comes to a deep question, well, how do you know that that database is the real size of the database? The answer might be, well, I can point to this particular paper by this particular person that shows that that's the case. Well, I want to question you on that particular paper. Well, outside of the scope of my expertise, you need that guy to come along. So that's the way, and I'm not sure about DNA in the US, but pretty much that's how the way DNA works in Europe and has worked in the UK. When all those challenges, initial challenges for DNA came up, Forensic Science Service had very, very clever, very intelligent statisticians, biologists, who knew the ins and outs of everything, and they were trot off to court to explain the ins and outs of how this worked. Over time, what happens is the defense give up because they find they can't find a suitable chink, or their challenges get so far beyond the jury that the jury can't actually understand what they're challenging. So that starts to diminish, and now you get less and less of those challenges. And that's probably what we'll see with this. Okay. But, and this is the exciting thing, maybe we can do something more with this software. Okay. We'll look at how we can use that software in our current process, how it can help us around things like NS report, as provide support. But is there something else that we can do with software? Perhaps we can do more. Okay, currently when we do our comparisons, and there's various different words from this, we have a certain number of correspondences between a latent and a print, but we offer no evidence. Or we say it's inconclusive. Or we say one of the myriad different phrases that you see around the world, which means, I don't know. Yeah, I don't know. Now that's probably a quite correct decision to make, because what you're saying, as we've shown, you're saying, look, there just isn't enough there to, as I said, float my boat. It just doesn't, push me into the point where I'm confident, based on my experience and my knowledge and everything that I know, that it's there. But it's giving this idea of inconclusive. But perhaps probability software can help us add some weight of evidence to those inconclusives. Simply, maybe we can measure how inconclusive that inconclusive is. And it's an interesting thing with inconclusive. If you think about inconclusive, and if this side of the podium is definitely conclusive, okay, this is my individualization, and this side is it definitely isn't him, where is inconclusive between those 2 points? Anyone like to guess? Is it in the middle? No, is it down this end? Can't be brave. Where would you say? In the middle?
It depends.
It depends. Yeah, so saying it's inconclusive sort of like means different things, different people are different. Well, one of the things is a lot of examiners actually say inconclusive means in the middle. I can say neither one or the other. Okay. What I can tell you on my very unscientific survey of lay people in the UK, and admittedly they're in the UK, so they might be a little bit, and you know, it's very unscientific. Asked them what inconclusive meant, and they said it's just below there. Inconclusive means, oh, so close to conclusive, I just couldn't make it. Which is a bit of a scary thing for me, because when I say inconclusive, I mean pretty much anywhere between those two, and I can't really assign how inconclusive it is at the moment. But they're thinking I'm almost there. So if you think about what that person on a jury was hearing if I said inconclusive, or somebody says inconclusive, it's not necessarily what we might have meant. So just branding things inconclusive may not be such a great idea. Okay. Should I just do on the floor? And if we can use this software, and if we can show how we can use this software to measure this inclusivity, is that a good word? How inconclusive these things are, that leads us into some brave new worlds. What about those current latent prints that we throw as no value? Okay, maybe some of those have got, what, 3, 4, 5 minutiae on them, but you know, for reasons, and I'm not saying that our reasons are wrong, we're saying, no, we're not going to do anything with that, we're going to throw that away. Maybe with this software, there's some value in that. Okay. And if we think about the total process of what we're doing, what's our job as forensic scientists is to assist the court in making a decision. So even if we provide very weak evidence, that could be of assistance to the court. Plus, we don't know all the other evidence. We don't know everything that's been elicited in that case. We're not privy to that. So we don't know that our little bit of, well, it's just likely it might be them, isn't going to be the turning point in the case in either direction, because this works both ways. This is not just about saying the person is guilty. This could actually say that this person is innocent. And what about those latent prints we don't recover? Hey, we all have CSIs working for us, except those who recover our own latent prints. So how do we tell a CSI which latent print we want recovered? You know, that's that sufficiency thing again, isn't it? What is sufficient for comparison? Well, is my sufficient for comparison the same as your sufficient for comparison? And then some people don't use sufficient for comparison. They say sufficient for identification. So they're sort of raising their bar even further. And we're telling a group of individuals who are often not fingerprint experts to go out to crime scenes and recover stuff that we can use in evidence when we can't really explain to them what we want. So maybe there's a whole untapped load of latent prints out there that we've just never looked at that could have provided us with good evidence. Okay, so we can consider a number of scenarios where to offer some evidence, however qualified, could assist the court in its deliberations. And that's quite easy to do. Let me take that back actually. That's quite easy to do. And the one I normally use sort of rather, again, ludicrous examples. There's no Amazons and fast canoes this time. But if you think about, well, think about your favorite president and he's lying in the Oval Office and he's been stabbed and there's a knife in his back and it's got 3 minutiae on the knife in his blood. All the doors to the Oval Office are locked, but you have 5 suspects. Okay, presumably from the US Secret Service, but yeah. You have 5 suspects. And you get a match of these 5 minutiae between that mark on that knife blade and one of those 5 suspects. Okay, and it comes out as a moderately strong evidence. In that sort of context and scenario, and okay, you can pull that apart in little flaws that there are in it. That evidence could be quite key. We're in a situation where a lot of the latent print examiners will say, well, that's insufficient. I can't even use that latent print. So the court doesn't hear anything about it. Others might say it's inconclusive, but then maybe inconclusive doesn't really mean much to that particular court. But with this software, you have the possibility of going in and saying, how inconclusive? Saying, actually, that's moderately strong evidence. There's a moderately strong connection. Oh, we can go further. There's a likelihood ratio of 2,000. It's 2,000 times more likely to come from that individual of the 5 suspects than another random individual or of the 5 suspects. So you're actually providing some useful information to the court to assist in its decision. Okay. That's very scary. That's a whole new ball game. That's something none of us are used to doing, but it is a possibility we should consider. But we can go off in another way. Okay, we don't like the idea of putting that in evidence. I have a lot of colleagues who don't like the idea of moving away from the individualization duality because they want to be able to just go to court and say it's an individualization. That's all they want to do. They do not want to go down the possible maybe route because they're worried about it. I'm not going to say they're wrong because I have some of the same concerns. We should be concerned about that. That's a big change. But another way we could use that is say, well, we're not going to give this in evidence. We're not going to use these qualified matches as evidence in a court of law. But what we could do is use them as intelligence to insist the inquiry. So this scenario, think of the same scenario. I'm not going to go to court and say it's 1,000 times more likely to be Greg that stabbed this particular president. But what I'm going to do is tell the detective, you want to look at Greg. He's your man. Okay. And if you take that out in another context, say you have an armed robbery, and say you have a lot of very low feature latent prints coming from these armed robberies. None of them are individualized to a particular suspect. But you search them on AFIS systems, and most AFIS systems can work on 3 minutiae. So you can search them on the AFIS system, you find a particular match. You get the same match from different armed robberies. None of them are individualizable. But you can put a weight of evidence on them using the probability software. Is there a detective that's not going to want to know that? That the last 5 robberies that took place in Largo were actually all matched to Greg, but not sufficient to individualize? Does that not give them something they can work on? Yep, we don't go to court on this. It's all agreed. DA agrees we don't go to court on it. So what are they going to do? They're going to say, well, okay, let's find out what we know about Greg. Well, Greg doesn't live in Largo, but hey, he was in Largo that week because he was attending a training course. It helps direct. And that's, again, another big use we've never used for fingerprints. Well, actually, we have. Back in the UK, when we had a 16-point numerical standard, if it was between 10 and 16, it was what was called a partial identification. And it was exactly what I've just described. We never went to court on it. It was accepted. It was never given in evidence. It was, can't go to court on it, but he's your man. And that's how it was used. And the detectives went off and found other things or whatever and did whatever it was they needed to do. So it can work, but it does need, obviously, a lot of people, understand those ideas. And is it scary? Yeah. Is it a great idea? I don't know. These are the ideas that we're floating and saying, this is what it could do. Is this beneficial? Okay. Reporting any conclusions other than individualization is going to need an enormous educational process right across the criminal justice system. I think I mentioned this before. There's no point in me going to court tomorrow and saying, you know, I've got this match and the likelihood ratio is 10 to the power 7, because no one in that court is going to have the slightest idea of what I'm talking about. So that's just not going to work. So we have to make sure that we do that. And that's, like I said before, with the United States and the legal system in the United States, and in fact in a lot of other countries, that's quite a difficult thing to do, how do you introduce such an innovation in a controlled manner. And that's what we termed adoption. I think a verbal explanation may win out on a numerical presentation. That's my view, because I think most juries will understand strong, weak, or whatever the words are, but numbers they will struggle with. However, I don't know, and I won't know until we sort of play with that. Maybe some of the graphical views you can have will be much better for juries to understand. We certainly need to get a bit more terminology. I mean, some of the terminology is a little fuzzy, isn't it? You certainly need to get rid of the word specificity, and have something that I can say. That would be good. But we need to think about the terminology that we can use and developing a nice, consistent terminology so that people understand what we're talking about. Because we don't have a consistent terminology at the moment. One of the very simple things, I think someone called it an enclosure on one of our exercises. Well, that's not an enclosure in the UK, that's a lake. In Germany, and that's an islet. Okay? Different words for different things. If we're a science, do sciences have different words for the same thing generally? They tend to have some consistency in terminology. So again, this is a bit broader than just the probability. Okay. So just to recap on that, if we're extending that scope, yeah, we're going to get huge challenge. the first person in court, and I was sort of worried this would be me, but I'm rather hoping it's not. Well, the first person in court that's going to go there with a qualified, there's strong evidence against this individual. Yeah, they're going to spend a little bit of time. Well, you guys sit, don't you? You sit on your stand. I have to stand on my stand. That's why it's called a stand. So, I'm going to stand there for several hours to explain all this, and we're going to troop in statisticians and computer technology people and all the rest of it to do that. And that's going to be big, and we can expect that. And a transition from our current practice, though, does mean more than that. And one of the things, and I've referred to this sort of Armageddon scenario, what would scare me and what worries me a lot is, say, one particular state adopts this and starts running with probability. They train everybody up nicely, and they're doing it properly, but the next state along doesn't. So you end up going to court, and you walk into court first day, and they say, well, why haven't you worked out a likelihood ratio for your latent print match? Well, at least you know what a likelihood ratio is now, right? So you can explain what it is. And you can probably explain that, my particular agency hasn't got any money to buy the likelihood ratio software or whatever it is. But, that's a real worry, because that's a big chink in the armor. Hey, well, down the road, they use this, you're not using it. So again, that adoption criteria, that management of how we change the process, should we decide to change the process, is very important. And I think where we are at the moment, we're still in that, is this worth any value? That's where we are at the moment. And we need to move from here, decide what the value is, and then look at how we do those adoptions. Okay. So like I said, it's the start of the debate, okay, and we got many questions. Big question, and part of what these sessions are about, is it understood? Well, immediately within the latent print community, I think there's a lot of people that don't quite understand what it is. Okay. So these sessions are important. Can we quantify the benefits? Because ultimately, unfortunately, it all comes down to money, doesn't it? Everything has a cost that we do. And it's very nice for me to stand up here and say, okay, you can get all these more latents from the crime scene. So you can deal with the casework you have now. So I'm going to increase your casework by 50%. And I'm going to increase it by 50% of poor quality latents as well, by definition. So I'm going to get you all doing that. And you're going to run likelihood ratios, and you're going to do this qualified reporting. But ultimately, if it doesn't get an end result, doesn't get something that's quantifiable, that money that costs isn't cost effective. And what we haven't been able to do at the moment is really quantify the benefits. So if you went to your chief of your police and said, I want to use Paul's software, I think Paul's software is going to be great, he's going to say, well, what's it give me? And you need to be able to say, well, I can give you X amount additional evidence. And if you say it's 2%, I might give you an extra statement every 2 in 100 times that I do a case. He's probably going to go, not really keen on that one. And I wouldn't be keen. As a chief of the latent prints, I'd be saying, well, that doesn't give me a great deal. But if I say, well, actually, I'm going to be able to do this, and I'm going to be able to increase the scope of fingerprints in your department, plus I'm going to be able to give you this intelligence, and I know that this intelligence is going to help with this, and that helps with that, and that helps, you can see how it builds. So the big bit that's missing at the moment is the sort of value bit underneath. How do you value this software in terms of its actual use in casework? And that's the bit that the FSS and others are working on now. Can we put some true value around that? But it needs you guys to help. And that's part of it, because you need to you're part of that chain that decides that value, as it were. The print community are the ones that can actually assess how useful this is going to be. And ultimately, someone somewhere or group of someone is going to say, well, how beneficial is this to the criminal justice system? And it's quite possible that an outcome of this is, actually, no, we'll just stick with where we are, guys. We'll just go for individualization and not identified. Everyone understands what it is. You're not going to get a great deal extra with the probability. The probability research and using the tool as a support is supporting what it is, so it's helping with scientific validity of your process. But that's great. That works for us. Everybody understands where we are. We'll stay with that. That's a possible outcome. There's no, we have to do this or we have to do this. It's all within the control of us as a community. Okay, so just to summarize, we've shown this first generation software, and it can measure the weight of evidence in minutiae configurations. Okay. We've identified, just very briefly, that we can implement it by developing this evaluation framework that will help us actually implement it into current process. it has fundamentally a supporting role. The big thing that this software does is support what we're already doing and support our current process. So that's a benefit, because some of us more and others are getting challenges around the NAS and validity of science, and we can only expect those to continue for a time. They're not going to go away tomorrow. Okay. It can provide us with potential report matches which cannot be individualized. There's a potential there, but we need to consider that development very carefully about what it brings for us, what the impact is going to be, how we actually do that if we think it's worthwhile. So that's basically where we are. Now, what I'm going to do is just summarize this impact probability. And when I do this graph, you can say, well, he could have just done that graph and we could have gone 20 minutes ago. Okay. So what I'm going to do, this is the graph, the entire graph you saw before, again, just simulating the likelihood ratios you get from the different number of minutiae. And I've drawn two lines on there. I've taken this 10 to the 6 as, if you like, you can say it's arbitrary, this point at which above 10 to the 6 is this diminishingly small. Likelihood ratio has got so large that I can say, I can forget it. Basically, there is no likelihood, or such a small likelihood I can dismiss, that this minutiae configuration came from another random individual. And the vertical line, I've just picked 8. And I've picked 8 because I was sort of told that 8 was a good point where most people below 8 don't tend to individualize, and most people above 8 will individualize. But if you're a 7 or a 6, you can just move that line up and down. Okay, it doesn't change the sort of impact of what we're going to say here. So the first thing we can see is this top quadrant up here. Okay, so we're working between 8 and 12, and you can see that the vast majority of the minutiae configurations here, around here, they're all coming up within that extremely strong support above 10 to the 6. Okay. So for the vast majority of comparisons of latent prints where you have configurations between 8 and 12 minutiae, the expectation is the likelihood ratio will be in that extremely strong, diminishingly low likelihood that another random individual left it. So it's providing very firm support for what actually we do in practice. Okay. The bit here is, oh, okay. Right, so we've got that support. One of the, right, sorry, I'm just getting confused now. Okay. Got it. Okay, if we go down and we look at lower, below 8 and 3, and we look at the number of minutiae that are there, we can see that we're dropping down below that 10 to the 6. The research is showing us that if you're relying just on the minutiae configurations certainly to individualize in that area, then maybe you're on shaky ground. But we already said, do many of us individualize between, say, 3 and 4? Some of us do around the sort of 7s and 8s quite regularly. Some of us go down into 5s. But what you will see is that some of those likelihood ratios are actually just popping up above that. So they're actually getting into that high level. But down there, fundamentally, the main area that we're interested in are these here, this group here, which are down below that level of individualization. This is where a lot of those latent prints that we throw away or don't collect are. And what we're saying is there is some additional evidence and intelligence there. These software tools allow us to use that. We currently generally don't use it. When we use it, do we use it only in serious cases? Is it something we only do for terrorist cases or for murders? Is it something we do every time we make an examination? Do we not do it at all? Those are the decisions that have to be made, and they will be based on fundamentally what it gives us in the criminal justice system. Okay. Now, the other group we have here is this group here that just drops below, and we've put this red flag on. Okay. Now this is the group that we mentioned again earlier in the day, where the likelihood ratio is dropping below what we would expect for that number of minutiae. It's not saying we got it wrong, but it's indicating that in these particular comparisons, we needed to rely on something else. Now, my view is that most examiners know that. We sort of talked about that before. You get that feeling, well, yeah, I got 8, but, you know, Owen, can you come and look at this? Because, you know, there's something about this that ain't right. Yeah, we've done that. We've all done that. And that's because that's where they fit. That's where we were working down there. And we knew that on basic experience. And what the model again is showing, yep, we were right to have those sort of cautions. But now if we use the model, it's going to actually point to some of those that we might have missed. So it's that red flag scenario. So as a sort of summary of that, fundamentally the model is about support, both in terms of individual casework if we use it, and in terms of the whole fingerprint process. Some of it is about these models could be used to extend the scope of fingerprints, either to an additional evidence on a qualified basis or additional intelligence and the use of intelligence. And it has this role of a red flag. And that's what this probability software does. None of that challenges individualization. Okay. Questions? I can say, nope. Well, I either did a very good job, or it's something to do with the time of day. Okay. Oh, sorry.
Do you have examples of prints that have low points but a high score?
You know, I don't have really good examples. And that's, there are a few that we have. We're not going to actually use them tomorrow. And the reason is that we want to concentrate more on the fact of the normal experience. Because those very low minutiae, very high light are fairly rare, let's be honest. There's not a lot of them around. Oh, we knew that. Because if they were very common, we'd already be reporting them. So no, we don't. And in fact, as a general thing, if anybody's got any latent prints and prints that, you know, fall into the things we talked about, those sort of, I'm not so sure about this type ones, or low numbers of minutiae in particular cases, I'm always happy to look at them and have a look to see what they do, because they're quite interesting to investigate.
This really supports the establishment of the point standards. I mean, you go down to 16,
okay,
down
yeah.
to 12, down to 8.
Good point. The thing with a point standard, and it's a good point because I should address this. The thing with a point standard is, could you have a scientifically based point standard? Well, not really, because your science there is going to, if we go back to the chart, okay, you could pick somewhere on there and say, okay, we're going to have our point standard. Well, we'll go 12, because my French colleagues were like that. We'll go for 12, and we say it's going to be 12, because I've already said above 12, yep, diminishing small, don't use new probabilities, that's fine. Scientifically, there's some support for why you picked 12, because you're pointing at this chart. But this chart is also saying, well, what about all those below? Because 12, all the way down here, you're going to have similar likelihood ratios. So yeah, you're picking 12 as a standard, but you're then ignoring any evidence between 6 and 12. Okay, that's not very scientific. So as a scientific standard, numerical standard, I don't think it's supported, because by it doesn't say that there is a one place where it is safe. And in fact, I think that's one of like the holy grail of fingerprints, to find whatever it is that's like the stepping stone, David Stoney's leap of faith. You know, get to this. When you get to this point, it's like bang. When I was training fingerprints in Scotland Yard, I was taught that. I was taught count to 16. When you get to 16, it's him. When it's 15, it's not him. You know, it never rang true to me then. I just don't believe it's like, life is not that easy, is it? Let's face it. So it's not so. Now, as an administrative standard, if you were to say, okay, well, we're going to make life easy in the French criminal justice system, and we're only going to use above 12 because we know it's very, very safe, and so that's what we're going to do. Absolutely, as an administrative standard. But as an administrative standard, we could do that wherever we wanted to. You know, you could say, well, actually, I'm going to have it 8. I'm going to put it in as 8 because pretty much I know the bulk of them are going to come up into that nice large likelihood ratio. I don't have to bother with the likelihood ratio software, and I'm fine. Okay, And I believe that some of our colleagues are sort of investigating ideas around this. Well, yeah, as an administrative standard, fine. Yeah, you can't knock it. It's a great idea. But what happened with numerical standards? Okay, let's look at the 16-point standard in the UK, which disappeared in 2001. Now, the 16-point standard came just from an accident in history. It was not developed as a scientific standard. It was the superintendent in 1920 decided to have 16. Okay, he sort of had a reason, but he decided to have 16. So, like I was taught, 16, 15, no. So what happened? Well, we then get this, as I talked about, partial identification issue. Okay, well, between 10 and 16, we can say it's him, but we're not going to court. Okay. The next thing we get is, if you are a senior latent print examiner with extensive experience, you can report an individualization with 10. Okay, but you've got to have a lot of experience to do it. So my numerical standard, like my threshold, is now beginning to be watered down. It gets worse. It's then, well, if you haven't got 10 on the finger, but you've got 2 simultaneous impressions and you've got an aggregate of 10 minutiae between the simultaneous, then you can call that an individualization as well. So they start to get blurred, and all the numerical standards being like that, they start to get blurred. One of the continental countries will tell you they adamantly is a 12-point standard. They never, ever report below 12 points. If you go and visit them, they will say, yeah, when we get one below 12 points and sort of between 10 and 12, what we have is we get a group of examiners together and we discuss it. Well, hold on a minute. You just said you had a threshold. The thing is that if you want to put it as an administration threshold, that's fine, but you then got to manage that threshold, because we all know that most, that we can individualize down. I think we have 4 or 5 people saying individualizing 5. So where are you going to put your threshold? 5? And if you put it higher than 5, you've just denied that evidence to the court. And I don't know in America, but in the UK, I'm an officer of the court. My responsibility is to the court of law. So it's my responsibility to give all the evidence I can to assist them, and I would not really be doing that. I'd be sort of stepping out of an ethical role and just sort of saying, well, I'm going to make my life easy. Any more questions? I promise the answers to the next questions will be shorter. Okay.